Good afternoon, students. I'm Dr. Lalit Thakur, and today I'm here to teach you a very interesting topic of manufacturing, which is called powder metallurgy. Many of you have already heard about this technique, and it is widely used in the industries, mostly in the automobile industries, aviation industries, to make products from powders. So let's move on to the background and the basics of this process. So this is a very old process, and it dates back to 3000 BC. And at that time, in the ancient period, also the people used to make products with the help of powders. And in the excavation, we have obtained different types of uh, uh, these powder metallurgy based parts that the people used to make for their different applications. However, in 1815, there was an Englishman, William Wollaston. He was the person who first commercialized this technique, or he developed this technique using platinum powders. Basically, he took some powders and then he consolidated all the powders in a die, and then he baked the compacted part till it became red hot. So powder metallurgy is a metal processing technique in which the products are made from uh, metallic powders, and the powders are compressed into desired shape, which is called pressing, and then heated to cause bonding of the particles in a hard and rigid mass, which is called sintering. So you take powders of different materials. Powder can be of metals, powder can be of alloys, ceramics, and mixtures. What do we call as a mixture of metal and ceramic? It is called composite. So last semester I already explained you about the basics of the composite and much details, different types of composite materials. So where is the application of this process, or the application of the parts being made with the help of this powder metallurgy? Uh, so almost 70% of the total products made by powder metallurgy, they are used especially for the automobile applications. So what are the parts? The parts are piston rings, connecting rods, brake pads, which are used to stop the vehicle, complex shaped gears, mainly spur types, very fine, having very good surface finish, and then cams to control the opening and closing of the valves. And a very special application is the oil impregnated bearings, which have controlled porosity. We will discuss these oil impregnated bearings in the upcoming classes. Then again, we use this process to make cutting inserts, which are made out of cermet material. We have already discussed what is a cermet material, and it is also used to make graphite brushes, contact brushes in the electrical motors, magnetic materials. We also use this process to make the metal filters, basically the filters for filtering different type of industrial waste. And it is very similar to the filters which are fitted in your home, just like RO filter. If you have seen some filters, pre-filters which are fitted in the RO, and you might have seen the repairing of these RO during some time in your home, and also used to make metal foams and surgical implants. So metal foams are special products, very popular nowadays, to make you can say shock absorbing. These are shock absorbing materials, and they are used in. So yes, you can see in this slide that what are the various types of products which we which we can produce with the help of this process. So here you can see piston rings, which are used in the slots given on the piston, and it seals the gap between the cylinder and the piston. And then a connecting rod, which is used to transfer the linear motion of the piston into the rotary motion of the you can say crankshaft. And then at the right top hand corner, we can see the different brake pads, the brake pad material, the gears, the cam which you can see here, that it is connected with the follower, and with the movement of this oval shaped cam, there is a linear up and down motion of the follower. And at the bottom, you can see there is an oil impregnated bearing. You can see this is basically a bushing, copper bushing, and you can see lots of porosity or porous features which are present on the surface. And there are it's a vast variety of powder metallurgy automobile components. Then you can see we can also fabricate metal filters for industrial applications, and these metal foams. It is very similar to the rubber foam which we see in day-to-day life. And then we have cutting inserts. We can produce these multi-shaped and multi-edge sharp cutting inserts for the metal cutting operation. And then this is a graphite bushes which we can use for electrical contacts in the electrical motor. And very interesting application in the aircraft application, which is basically the landing gear components. So you can see here in the figure, is a landing gear through which your aircraft lands on the surface while it return back to the highway, runway. And you can say that frames, this engine frames, in which different engine components are mounted. Also, there is a picture of gas turbine where we have, you can say, these engine discs. Engine discs are fitted, and on these engine discs, different I can say different blades or fan blades are mounted, which are used to transform the combustion energy into the mechanical energy. Mostly the powder metallurgy parts are less than 2.5 kg. However, for the industrial application, we have seen the parts more than 20 kg have also been developed. Okay, now let's discuss about the basics of this powder metallurgy process. So the first step, you select the powders of different materials, maybe of metal, it may be of alloy or ceramic, and as per your requirement. You know that if you want to make a product of lightweight and high strength, then you can go with the aluminium powder and aluminium alloys. Similarly, for extra light material, extra light component, we can select the magnesium alloy powders. We can also select the steels. We can also select the copper alloys, and it all depends upon the application and as per your requirement. So you take different powders of different composition and in different proportions, and then you mix all this powder in a mixer, in a mixing device. So in the mixing device, these are of different types. We have different types of mixing devices, which we will study in the coming classes. And during the mixing, which is also called as the blending, you might have heard about the blending of the paints, the blending of different materials. We also add some certain lubricants and additives. What is the role of lubricant and additives? These help the powders to mix thoroughly and to make a uniform mixture. Lubricant is basically also sticks on the surface on the powder particles, and then this powder mixture is poured into a die cavity. You can see down to the process after mixing. There is a process, there is a stage called compaction or the compacting. You see here in this particular slide that there is a, die and punch arrangement, and in the die the bottom there is a bottom punch, and at the top of it there is a top punch, and then you fill the powder your powder mixture into this die cavity, and then you press this powder can say the powder mixture to a particular pressure or particular level, uh, which causes the densification of the powder particles. Means there is a cold, you can say the deformation between the powder particles, and there is a, sort of cold welding among the powder particles. So now this compaction process is also of different types. There is a compaction which is taking place at room temperature. So this is called the cold compaction, and the compaction which this can also takes place at the high temperature. Then this compaction is called hot compaction. Then after this process compaction, you have a solid rigid mass, but you can't use this particular fresh product for the industrial applications, because it has still lot of porosity in the you can say in the part. So this porosity, you all know that with the porosity, it causes further problem in this degradation of the strength and some mechanical applications. So we need to reduce this porosity, and we have to achieve this the proper bonding between the particles in order to achieve the required strength, which is a requirement for a particular industrial application. So what you do then for further densification, there is another step which is called as the sintering. So sintering, what is sintering? Sintering is basically the process of heating this solid or densified mass, which you have obtained after the compaction process. Uh, then you heat it below its melting point. So basically, there is a range of the temperature, and it entirely depends upon the melting point of a material. So what is that range? So that range is basically 0.75 to zero point 0.9 times the melting point of that particular material out of which you have made your product. So this is a very you can say complex process of sintering. We have to take care of different parameters, and we have to select the sintering time. We have to select the temperature ranges. It doesn't happen that you just take your compacted part and just put it in the oven and furnace, and then you heat it to zero point 0.9 times the melting point of that material. So this is basically a very long process and a very time consuming process, and you can see this sintering process is divided into three different zones. The first zone is called the preheated zone, the second zone is called the hot zone, and third zone is called the cooling zone. And after this sintering process, you can achieve almost 95% of the theoretical density, but still 5% of the porosity is left, and you cannot say that your product is 100% dense as compared to the bulk material. Then after this, certain secondary treatments or secondary operations are required, which further improves the quality of your product.